We're now going to talk about how to program with Java's structured concurrency model. And we'll talk about the classes that are used, which are defined in this Java extension that is being evaluated as part of the new versions of Java. So it's this JEP 428, structured concurrency. So as we saw in the overview, Java's structured concurrency model enforces a hierarchy of tasks and subtasks. And as you can see here, the parent task can have multiple nested levels of subtasks. It doesn't have to just be one level. And some of the examples we'll look at actually demonstrate that ability to have multiple levels of nesting. However, the lifetime of a subtask is always confined to the syntactic block of the task that creates it, which is known as its parent task. And all of these subtasks must complete before the parent task can complete. That's another virtue of doing things using this particular model. Within a scope, you have sibling subtasks. These are the ones that are forked and created to run. And as you can see here, they're nested within their parent task, and this can be nested to arbitrary levels of nesting. So you can have subtasks within subtasks within subtasks if you need that much nesting. Usually you probably don't, but if you need it, it's there for you. And what is nice about this is it allows us to reason about tasks and or groups of subtasks and manage them collectively as a unit, which is what you don't get if you just have virtual threads or threads that are spawned in a free threading model where things can outlive their parent scope. It would come as no surprise that structured concurrency is a great match for virtual threads because we have the ability to have many, many lightweight virtual threads that can run within these scoped groupings using the structured concurrency model. Because virtual threads are so lightweight, they can represent any type of concurrent behavior. You can have tasks that are compute bound. You can have tasks that are IO bound. There's an example that we'll take a look at that involves IO bound tasks where we do things like download images from remote web servers. And as you can see here, one of the nice things about virtual threads is that's okay. Having things running in multiple threads is not a problem with virtual threads if those threads block, because if Java Virtual Machine and Java 19 and beyond has been carefully updated to handle blocking virtual threads without causing all kinds of other consternation, which would have been the case with traditional types of threads. Structured concurrency ensures that these virtual threads are correctly and robustly coordinated. For example, the use of the join method here provides a barrier synchronizer that ensures that the block of code doesn't exit until all the images at this scope are downloaded. Java structured concurrency is evolving. It's not static. So what happened in Java 19, they added this thing called StructuredTaskScope, which is kind of the parent of all the different variants that come out of the box with Java. And this can be used to split a task into several concurrent subtasks within a syntax block, as you can see here, like we looked at before, where you are going to download images in separate virtual threads and then wait for them all to finish within this try with resources block. And this was added in Java 19 as a so-called incubator feature. And an incubator feature is a feature that's designed to get feedback from the community. It may go on and be birthed after it's been incubated and become part of standard Java, or it might be removed if people don't like it, or it has other issues. And that's why when you use the Java incubator concurrent package in Java 19, you get this funny warning that says, warning, using incubator models. And all that means is don't count on this being exactly the same over time. There's also another mechanism that's been around for a little while called the new ThreadPerTaskExecutor, or new virtual ThreadPerTaskExecutor. And this has been added to the Java executors framework. And what it does is it uses executor mechanisms, which have been around for a long time, since Java 5, in fact, but now they've been upgraded to start new virtual threads for each task within a syntax block. So we'll cover this example here again shortly, but you can see that you can create a new executor, and then within the executor, you can spawn or submit different tasks to run within either a thread or a virtual thread. And that's also quite interesting. This was added in Java 19 as a so-called preview feature, which means it's mostly finished and ready to be standardized, but they're still waiting for some feedback from the user community. So it's a little bit further along than something in the incubator stage, but it's not completely baked yet. You won't find as much information about the ThreadPerTaskExecutor or virtual ThreadPerTaskExecutor because it's not as well versed, it's not as featureful as the StructuredTaskScope. It's more limited. And we'll talk about some of those limitations here shortly. So that's the end of the overview of programming with Java structured concurrency.